Hey everyone, today I'm going to show you TradeBench, our distributed platform we built that lets trading algorithm team submit the exchange engines and compare head to head under real load. The idea is simple. You upload a zip containing your exchange server, we build it, run it in a sandbox container, hit it with thousands of bots firing real orders, measure your latency and throughput, and put you on a live leaderboard. I will walk you through the full pipeline in real time: upload, build, benchmark, score, and leaderboard. So let's go. So you can see the high level architecture of our project. Here's how it works at a high level. There are 6 services running in Docker. The API gateway handles submission and the leaderboard. The sandbox engine pulls job from Redis streams, builds the Docker image from the submitted zip, spawns the container with strict security constraints, read only, file system, cap memory, and CPU. Isolated network. These are necessary for ensuring the system stays up and secure. Then health checks it. Once the container is healthy, it fires a gRPC call to the bot feed, which runs a 5-phase load profile against your exchange. First is warm up, then ramp, sustain load, spike, and then drain. Every bot event streams to the telemetry ingester via gRPC. It aggregates metrics in 10-second window, computes a composite score. Here is how the score is calculated: 40% for throughput, 40% latency, 20% correctness, and writes it to the leaderboard. The front end shows it all live via SSE. Everything is Go, Postgres with TimescaleDB, Redis streams, Docker in Docker. Yes, it is nested. Of course, gRPC. Let's see it running. Okay, so we are going to show you the platform, and oops, the platform is, where is the platform? Oh, so it's at the center, no problem. So you can see it's looking pretty. So okay, before the platform, let me show you uh, something. Okay, so let me show you what are the running processes here. So you can see all 8 services are up. Postgres is healthy, and you can see the gateway is running. Bot fleet is up. Front end is running at 3000, and Redis is up. Sandbox is also ready, and telemetry ingester is also ready. So let's submit something and go to the leaderboard. Okay, here it is. So you can see we have made it pretty. Okay, so uh, before we submit, let's walk you through how and what to submit. So here you can see we have built. This is what the zip would look like if unzipped. These are test submission, a simple Go HTTP server that implements the Exchange API, health endpoints, order placement, cancellation, order books, etc. It's not a real-time engine, just a stub that accepts everything. We'll see how it works. Okay, you can see there. The rules are pretty simple. You have there's a submission, um, a guide that you can follow. I've uploaded in my you know um, repo. Your zip must have a Docker file. You can see the Docker file there. Must have a Docker file, and should have a go.mod and main.go. You should zip it properly, and you should expose ports to 8080, and you should have to respond to health endpoint with a 200 when it's alive. Okay, these are the bare minimum. So let's do the real thing. Okay, so let me upload something. I have this file. Okay, that's ready. Let's name in something like 5 star. Great. The bearer token is for safety, that no same, even if the team name is same, the token won't be same. It can be anything random text. So here you can see the process has started. Okay. What's the status tracker? We are now we have built and we are sandboxed and we are now at benchmarking. Great. Now benchmarking, the bot fleet just got to the signal via gRPC and started a load profile. Okay, let's see what's happening under the radar. You can see here are the logs which I have made. On the left of the screen, yes, you can see the pipeline tracker live. On the right, the bot fleet logs. And the warm-up phase, 50 bots ramp up to 200, sustain 100 bots hammering the exchange for 60 seconds. Then the spike and then drain. Every bot fires post order, delete order, get order on realistic distribution. 35% limit buys, 35 limit sells. Okay, 20% market orders and 10% cancels. The telemetry ingester is collecting every response time and computing rolling P50, P90, P99 latency and TPS every 10 seconds. You can see it's pretty nerdy. You can see the window ticks 1000 events per window, P99 around 300 milliseconds, and around 500. TPS is around 500. Score is computing every 10 seconds. Great. So let's see what the result is. So okay, you can see it's done, and the final score you can see here is around 27.5. It's low. Okay. Throughput score is low. Our stub doesn't actually process orders, just accepts them. Or real TPS is limited by the continuous single-threaded HTTP handler. Latency score is decent, P99. Okay, you can see it's red because of the system on which. Okay, on a good device, I have a MacBook Air 2017, which is i5, and it's pretty old. So you can see this is due to the local system's performance, and a real machine engine with proper concurrency would push throughout much throughput much higher. Okay, so we need to see the leaderboard. Yes, you can see that it's real time, so it's updating. It was 27, now it's 20. It changes through gRPC, and here we are on the leaderboard. The team is ranked, score visible like by SSE, and new submission update. This is in real time without page refresh. Great. So let's do some technical talking, and yeah, some things which should be mentioned. Every submission on the first, you can see security ops we have grabbed. This shows that every submission container runs with no new privileges. For security, of course, all Linux capabilities are dropped. Read-only root file systems. Okay, temps and TMP. Okay, PID limit of 128, and the storage is 512 MB of memory cap. One CPU core is allowed, and network isolation on BenchNet. Okay, you cannot connect to the internet, so any malicious code won't run here. No internet access. A malicious submission literally cannot accept. Okay, cannot escape. You can see the XRead group which we grabbed shows job flow through Redis streams with consumer groups. If sandbox engine crashes mid-build, the job stays in the pending entries list and gets redelivered, not lost. So this is also something which makes our program consistent. Okay. And the last, gRPC telemetry. We can see stream events. Bot events stream to telemetry ingester via client streaming gRPC call, which is real time. The ingester buffers 100,000 events in a ring buffer and drains on 10-second ticker. Handlers 10,000. Oh, what I said. Handles 10,000 concurrent bots without dropping data. So this is for real-time concurrency and without data loss. So these are things, and to your surprise, we have built a CI/CD pipeline so that any future code pushes are verified automatically. We have full CI pipeline on GitHub Actions. Every pull request runs 29 units test across all services, and it is about 90 seconds, I guess. Every push to main runs on the Docker build with layer caching. And the full end-to-end test against a real platform stack, upload, build, benchmarks code, verify the leaderboard. The whole thing takes around you can see 6:54 minutes, and I have seen 7 to 8 minutes. The E2E job is the same. Make test E2E. It just runs the E2E test suite script, and we just ran locally, running on a GitHub runner. So I just when during local development, make test E2E was what I designed to check if my flow was correct. So this action just uses that. Okay. So ending with what? That's our TradeBench, full distributed benchmarking platform, submission, ingestion, sandboxed, Docker execution, real bot load testing, live telemetry, composite scoring, live leaderboard, built in Go across 6 services in about a week. No, it took more than that, around a month. Okay, the code is on GitHub, link in the description if you want to submit your own exchange engine. Check the submission guide.md we have in our repo. It tells you exactly what endpoints implements and how to create the zip. If you found this useful, like, subscribe, questions in the comments.